Scene script. Ever pondered how a world of plenty still grapples with hunger? And what's good old math got to do with it? Welcome to the perplexing paradox of our planet. We live in a world where some have more than they can eat, while others don't have enough. A world where food wastage is as much a reality as hunger. A world where abundance and scarcity walk hand in hand. And amidst this paradox, we're left scratching our heads, because something just doesn't add up. That's where mathematics steps in. Yes, you heard right. Mathematics, the subject you probably thought you'd left behind in high school. But trust me, it's more than just a bunch of numbers and equations. It's a tool, a lens that can help us understand and solve real-world problems, like hunger. Now you might be wondering, how can numbers fill empty bellies? Well, it's not about literally feeding equations to the hungry. It's about using mathematical models to understand patterns, predict outcomes, and make decisions. It's about optimization, maximizing resources and minimizing waste. It's about finding the most efficient ways to produce, distribute, and consume food. It's about making sure that every mouth gets fed and no food goes to waste. But it's not just about the numbers. It's about the people behind the numbers. The farmers who grow our food, the scientists who study our soils, the policymakers who make our laws, and the activists who fight for our rights. They're all part of the equation too. So imagine if we could harness the power of mathematics to solve the hunger equation. Imagine if we could use numbers to ensure that everyone, everywhere, had enough to eat. Wouldn't that be something? Well, that's exactly what we're going to explore in this video. We're going to delve into the fascinating intersection of math and munchies. We're going to see how numbers can help us understand and perhaps even solve one of humanity's most pressing problems. So buckle up as we dive into the world of numbers and nosh. Did you know your love for pizza could be expressed in a mathematical equation? That's right, folks. Just when you thought pizza couldn't get any better, we're adding a dash of mathematics to the mix. Now don't fret, we're not about to turn your favorite Italian pie into a dreaded algebra problem. Rather, we're going to use this delicious example to unwrap the concept of mathematical modeling. So, what's mathematical modeling, you ask? Well, imagine you're at a pizza party. Around the table, there are different types of pizza lovers. There's the one who's all about the toppings, the crust enthusiast, and of course, the cheese fanatic. Each of these pizza preferences can be represented by a mathematical model, a sort of mathematical language to explain their pizza love. The topping lover's model might be something like more toppings equals more love, represented by the equation love equals sine toppings. The crust enthusiast might have a model like love equals sine crust, because their affection increases exponentially with the thickness of the crust. And the cheese fanatic? Their model could be love equals sine cheese 3, because the more cheese, the merrier. But here's where it gets truly interesting. Mathematical models aren't just for pizza parties. They're powerful tools that help us represent and understand complex real-world situations. From predicting weather patterns to planning city infrastructures and yes, even addressing world hunger, mathematical models play a crucial role. Just as we used variables like cheese, crust, and toppings to represent pizza love, we can use variables like food production, population growth, and resource allocation to create a mathematical model of world hunger. This model can then help us understand the problem better and find effective solutions. So, there you have it. Your love for pizza and the fight against world hunger, all wrapped up in the universal language of mathematics. Who knew math could be so delicious? So, next time you're fighting for that last slice, remember, it's all just a part of the grand mathematical design. Ever wondered why a mathematician never gets lost in a supermarket? Because they always have their coordinates right. Now hold on to your shopping carts and let's dive into the world of coordinates. Imagine a supermarket as a giant grid, with aisles and shelves mapped out like lines on a graph. You're standing at the entrance and you've got your eyes set on a pack of those irresistible chocolate chip cookies on aisle 5, shelf 3. In the world of mathematics, this journey is a simple matter of moving along the X and Y axes. You walk 4 aisles down the X-axis and then make a right, moving 2 shelves along the Y-axis. Voila! You've reached your delicious destination. But what if we were to apply this concept on a much larger scale? Say the entire globe. When we talk about world hunger, one of the key challenges is distribution. We've got enough food to feed everyone, But getting it to the right place at the right time is a logistical nightmare. Enter the power of coordinates and mapping. By using mathematical models, we can map out the areas of greatest need, the food sources, and the most efficient routes to get the food from point A to point B. We can even predict and plan for changes in demand or supply, ensuring that everyone gets their fair share of the pie, or in this case, the world's food supply. Let's not forget about the time factor. With the help of mathematical models, we can calculate the fastest routes, minimizing the time food spends in transit, and ensuring it gets to those in need while it's still fresh and nutritious. Mathematics, my dear friends, is not just about solving equations on paper. It's about using those equations to solve real-world problems, like world hunger. So, the next time you're lost in the snack aisle, remember, coordinates to the rescue. Why does a mathematician never play hide and seek with their food? Because they know the best hiding spots are always at the intersection. Now you might be wondering, what does a game of hide and seek have to do with mathematics and world hunger? Well, that's exactly what we're about to dive into. You see, in mathematics, an intersection is the point where two lines meet. It's like a crossroad, where different paths converge. But how does this relate to world hunger, you might ask? Let's think of world hunger as a massive game of hide and seek. The food is out there, but it seems to be exceedingly good at hiding. We have the players, that's us, the world population, and we're all seeking. Our task is to find the food, but it's not as simple as just looking under the couch cushions. In the game of hide and seek, the best hiding spots are often at the intersection of multiple hiding places. Similarly, the solution to world hunger lies at the intersection of various factors: agriculture, economics, climate change, and so on. For instance, think about agriculture and economics. At their intersection, we find concepts like efficient farming practices and fair trade. And at the intersection of agriculture and climate change, we discover sustainable farming methods that are more resistant to weather variations. So you see, the game of hide and seek suddenly becomes a lot more complex. We're not just looking for food, we're looking for the intersections where solutions to world hunger can be found. It's like being in the Hunger Games, but instead of fighting each other, we're working together, using the power of mathematics to uncover the best strategies. By understanding the intersections, we can start to see the bigger picture, and the solutions become clearer. It's a daunting task, no doubt, but with the right approach, we can turn this game of hide and seek into a victory for everyone. So, if you ever find yourself in the Hunger Games, remember, the intersection holds the key. So, how can we use our mathematical prowess to banish hunger? Well, let's tie it all together, shall we? First off, we've got our hunger equation, remember? The one where we balance population growth, food production, and distribution. Now, this isn't the kind of equation you'd solve on a lazy Sunday afternoon. It's more of an ongoing, dynamic equation that needs constant tweaking and adjusting. But don't worry, we've got the math tools to get the job done. Next, we take a look at farming practices and food production. Mathematical models can help optimize crop yields and figure out the most effective use of resources. That means more bang for your buck when it comes to feeding people. It's like having a superpower, but instead of shooting lasers from your eyes, you're solving hunger. Now, we can't forget distribution. That's where logistics and transportation come in. Mathematical models help optimize routes, ensuring that food gets where it needs to go while wasting as little time and resources as possible. It's like a big, complex game of Tetris, but instead of fitting blocks together, we're fitting food into the bellies of those who need it. We also have the power of predictive analytics. By using historical data and mathematical models, we can predict future trends in population growth, food production, and even climate patterns. This means we can better prepare for and prevent future instances of hunger. It's like having a crystal ball, but instead of seeing your future self lounging on a beach, you're seeing a future where everyone has enough to eat. Lastly, we use math to measure our progress. By using statistics and data analysis, we can keep track of our successes and learn from our failures. It's a constant feedback loop that helps us improve and fine-tune our strategies. And there you have it, folks. A world free of hunger, all thanks to a little number crunching.